Acids are important in chemistry. They're great sources of energy. And all acids have hydrogen ions. And most of the time, all right, acids will have an H+. That's the most common kind of hydrogen ion. There is a hydride, H- one, but those are more rare. H+ by far more common. So if you have an acid, you list the H first. It's really important. That shows the chemist that is an acid, and that's going to be a really important part of your molecule. Here are some common acids. HCl, hydrochloric acid. HNO3, we saw earlier, nitric acid. HClO4, perchloric acid. H2SO4, you may have heard of, sulfuric acid, and there's a whole bunch of other ones. So, for example, HBRO, hypobromous acids. We're going to look more at acids in Chapter 4, and also the nomenclature lab for Chem 221 will be helpful in figuring out what acids are all about. But for right now, just realize acids are acids because they have a superactive H+ somewhere in the molecule. And knowing where the H+ is important. That's why the H+ is listed first. Acids and bases are complementary to each other. And acids and bases, if you have them interact, you get a lot of energy out. So a base is just as important to chemists, if I would argue, as an acid. So while acids had H+ as their thing that made them acidic, bases are metal hydroxides. And a hydroxide is a polyatomic ion we talked about earlier. It's OH-. So bases are essentially sources of hydroxides. And if you have the hydroxide with a metal, you're going to have a base. The most common base by far is sodium hydroxide, NaOH. Now, Na always +1, and OH- hydroxide always -1. They come together 1-to-1, sodium hydroxide. If you've ever used Drano at your house, that's essentially a sodium hydroxide solution or sodium hydroxide pellet. KOH, potassium hydroxide, fairly common. LiOH, lithium hydroxide. Calcium hydroxide, pretty common. Now, calcium is a +2 metal, and hydroxide still -1. So you need 2 hydroxides. That's why it's Ca parentheses OH parentheses 2. 2 hydroxides for 1 calcium. And you can have the variable charge metals as well. So, for example, iron 3 hydroxide is a compound. It's a +3 iron. Hydroxide's -1, so you need 3 of them to make it Fe parentheses OH parentheses 3. And again, we're going to look more at bases in that same Chapter 4 section and also in the nomenclature lab.
When the hydrated compound, copper sulfate pentahydrate, is heated, the water molecules associated with the ionic solid are driven off, leaving copper sulfate with no associated waters. This compound is called anhydrous copper sulfate.
Hydrated compounds are pretty common in chemistry. On the Earth, we have a lot of water. And we're going to see that a lot of the metals, especially the transition metals, can take some of those waters and kind of glue them on to themselves. It's kind of hard to explain right now, but we'll talk about that this year. So a hydrated compound is just a regular compound, for example, copper 2 sulfate here, with some waters on it. So this CuSO4.5H2O, that's an example of a hydrated compound. Now, an advantage of the hydrated compounds is that, man, their colors are just freaking awesome, all right? And I just love the colors of the transition metals in water. They're really spectacular. I use beautiful here with the highest respect because it's really cool. If you heat the hydrated compounds, you'll make the same compound but without the water, and the waters will evaporate as a gas. That's what that means. So CuSO4 without the water, you would call that an anhydrous compound, which means without water. So CuSO4 is copper 2 sulfate. Copper 2 sulfate without the water would be anhydrous, and with it you'd say you had a hydrated version of copper 2 sulfate. It's pretty easy to name hydrated compounds. You just call the name what it would be normally, and then a Greek prefix hydrate after that. So that CuSO4.5H2O was copper 2 sulfate. Sulfate is -2. Copper, a variable charge metal, has to balance the -2 sulfate with a +2. So that's copper Roman numeral 2, copper plus 2, copper 2 sulfate. But because it's a hydrated compound, we're going to put 5, penta is 5, and then hydrate. So copper 2 sulfate pentahydrate would be the name of that hydrated compound. Another common one you'll see sometimes at the Fred Meyers even is MgSO4.7H2O. MgSO4 is magnesium sulfate, and because there are 7 waters, 7 is hepta, that would be magnesium sulfate heptahydrate. The next compound is nickel 2 chloride hexahydrate. Chlorine as chloride is -1, and there's 2 of them. So the -2 is balanced by a +2 on the nickel 2 chloride hexahydrate. And again, if you evaporate the water, which is usually possible, you end up making anhydrous versions. So if you hear anhydrous copper 2 sulfate, that just means it's copper 2 sulfate without the water.